Hello guys, welcome to another video. In this video we would be seeing what is timely stream processing. In the previous video I have uploaded the PPT slide in my YouTube channel which explains the stateful stream processing, and now in this video we will see what is timely stream processing and what are all the concepts we need to be aware in timely stream processing. So timely stream processing is nothing but processing the streams or stateful streams based on the time, like in some specific window or in some specific interval. That's called the timely stream processing on a high level. Timely stream processing is extension of stateful stream processing in which time plays some role in computation. Among other things, this is the case when you do time series analysis, when doing aggregation based on the time periods. Here we need to know two things: what is event time and what is processing time. Event time is the time when the event has occurred in our source, like it can be Kafka, any other stream provider where the event has occurred. That's the time at which the event has occurred is called event time. And the processing time is nothing but the system time where the Flink is running. Now if you see more detail, event time, the time when an event actually occurred, typically encoded in the event itself. So whenever we get the stream or events, in that event itself, this event time will be encoded. I mean the Kafka, let's assume if the Kafka is generating the stream, the Kafka will send the event time as well along with that event. Event is nothing but the data, we can call it as in the stream data. Essential for scenarios where the analysis depends on true event, when you have to do the analysis based on when the event has occurred. For suppose clicking, if you are doing some analysis and the user clicks on a website, then that time we consider the event time. Processing time is when we are processing the data. We get the events continuously, but processing time is when our Flink system processes that events. If you see the time when event is processed by the Flink system, suitable for scenarios requiring low latency and where event delays are less critical, like there can be delay in the events, that kind of scenarios we use processing time. Just to sum up, processing time is when we are processing, event time is when that particular stream or event has happened. So this is the difference. This slide has a difference. Time embedded in the event, time when the Flink processes the events. Handles late out of the order events gracefully, cannot account for delays in the data arrival. More accurate for time based analysis, less accurate due to reliance on the system clock, because the time here is when our system or a Flink system process the data. Here we do it with the event time, we do it with the watermarks. So we'll see what is watermarks, and we don't need watermarks here because we don't worry about the late arriving records. So what are watermarks in Apache Flink? So let's assume we have a scenario where we are getting events like E1, E2, E3, E4, and we got E1, E2, E4, E5, E6, and E3 gets late. E3 comes after E6. Those kind of scenarios is called out of order events. So I mean the order is missed here. So that's called an out of order event. This is the definition of the watermark. They represent a point in the event time up to which the system assumes it has received all the events. For suppose we have an event as E1, E2, E3, E4, E5, E6. So we have 6 events. And let's assume they are coming in the timestamp T1, T2, T3, T4, T5, T6. And if we make the watermark as T6, then we are saying like till T6 we have received all the events. We have got T1 to T6 every event. So the T6 is called a watermark here. Why are watermarks important? Out of the order events. That is, in the real world streaming systems, events often arrive out of the order due to the network delays, data shuffling or buffering issues. So for accurate results, Flink needs a mechanism to decide when to close the event windows, even if the late events might still arrive. So for suppose, as I said, if we are having the events from E1 to E6 and if E3 comes late, we watermark E6 and we process that events and we handle differently the E3 event which comes late or the T3 event. How do watermarks works? So as I said, in every event we get the timestamp, right? So in the source itself they generate the timestamp and send. So watermarks are generated by the Flink. We have a predefined watermark generator, or you can have the user defined as well. I mean watermark is nothing but a time period which we select and decide that we have received all the events till this point in time or till this time period. As the events keep on coming into the streaming system, their timestamps are compared with the watermark. So if you see, if the event timestamp is earlier or equal to the watermark, then it is considered as on time and processed immediately. If the event timestamp is later than the watermark, it's an out of the order event which we have discussed before. So we will see how do we handle these watermarks as well. So let's see what is relation between the watermarks and event time. Watermark, like just on a level, watermark is nothing but a specific point in time in an event time. That's it. Watermarks are directly tied to the event time and provide a mechanism to track and progress the event time in a distributed system. I mean, in case if you have multiple source systems, so to track the event time in a multiple systems, we use watermarks. I mean, watermark is used to manage the challenges of out of the order events. I mean, I just explained what is out of order events. So just on a high level, the watermarks and event times are interlinked. And watermark is nothing but a specific point in time in the event time. That's it. A watermark with a timestamp 12 tells Flink that it can safely process all the events with timestamp up to and including 12. What are late events? So events which are generated before the watermark only in the source, but they arrive after the watermark timestamp, they are called late arriving events. So how do we handle them? We can either drop them, or else we can route them to the another system, and there we can handle all the late arriving records, or else we can allow latency as well. So we give the watermark, and again we give we can say I will have to wait for 1 more minute and process. So if those late arriving records comes in those 1 minute, then we can process those. So we can allow latency in our system so that the late arriving records can be handled. You can configure and allowed latency period during which the late events are still processed. We can add that option, which I'll show in the practical class. So how are watermarks handled if it is a single system? Then watermarks can be handled very easily with the options which we saw here. But how are the watermarks handled in the parallel systems where you are getting the data from multiple sources? So when dealing with event time processing in parallel streams, managing watermarks across multiple parallel subtasks becomes essential to ensure consistency and correctness in processing out of the order events or the late events. So what are the challenges in parallel streams? Each parallel instance or each stream has its own independent watermark generator to ensure that the event times being processed in each stream or in each partition or in each subtask, Flink needs to compute the global watermark as well. I'll show you how the global watermark can be calculated for all the subtasks. So handling of out of order within each partition or each subtask is also a big challenge. So these are all the challenges which we face with the parallel streams, and we have to handle those using watermarks. So how do we handle those? One is per partition watermark. So each partition or each subtask or each source system should have one individual watermark generator, and then we'll have a global watermark. So the Flink computes the global watermark, and no records with timestamp earlier than the global watermark are expected from any subtask. So if we just take the minimum of timestamp from each subsystem, here if we have n subsystems, we just took the minimum here, and none of the subsystems should have the records which are less than that minimum watermark timestamp. So like this we can handle later arriving records in the parallel systems using watermark. It's about timely stream processing in Flink, where we need to understand what is watermark and what and how the watermarks are handled when we have the parallel streams, and what is event time and what is the processing time. That's it. Thank you so much for watching.